Module 1, Objective 12, be able to identify the basic structure of an amino acid and understand how amino acids link together to form polypeptides in proteins. Proteins are the most abundant and arguably the most important organic macromolecules. Remember, if we take the body and pick it apart molecule by molecule, we'd have four large piles. We'd have a pile of carbohydrates, a pile of lipids, a pile of proteins, and a pile of nucleic acids. Well, proteins would be the most abundant, the largest pile. They contain carbon and hydrogen, oxygen and nitrogen, and they're made up of a building block or a monomer called an amino acid. And there are 20 natural amino acids in nature. And here we see the chemical structure of all 20. So amino acids are the monomers, while proteins are the polymers. So proteins are basically long chains of amino acids that are all linked together covalently. And if we consider the structure of an amino acid, we can see that all 20 amino acids share this similar structure down here in this image. They all have a centralized carbon that is attached to a hydrogen, a carboxylic acid group. We just saw that before. So here we have a carboxylic acid group. It's also called a carboxyl group. We have an amino group. Okay, this is an amino group. And then we have this R. And this R refers to the variable group. So all 20 amino acids that are known, and I'm going to go back to that image, all 20 of these have a centralized carbon attached to a hydrogen or carboxylic acid group, an amino group. What differs between these 20 amino acids is this R group. You can see this R group is a long chain. Some of them have rings. Some of them are very simple. Glycine, the R group on a glycine is a simple H, or a simple hydrogen. CH3 is alanine. So they can be very simple, they can be very complex. I'm not asking you to memorize them. Just know that there are 20 different amino acids naturally occurring in nature, and the basic structure, the fact that all amino acids have a centralized carbon bonded to a carboxylic acid group, an amino group, and this variable side chain that is often labeled R. We link two amino acids together through dehydration synthesis. And again, in dehydration synthesis, we liberate a water molecule. In doing so, we create a new covalent bond between the carbon in this carboxylic acid group and the nitrogen in this amino group. And this new bond is called a peptide bond. It is just a special type of covalent bond. So it is a covalent bond that's called a peptide bond. And this is how proteins are made.